Hi, welcome to the HoloLens session. I'm Rob Tiffany.
And I'm Rocky Ekman, and we don't have a HoloLens.
Lock the doors.
So Rocky Ekman is doing a HoloLens session, and he'll repeat that again tomorrow for those of you who would also want to see that one. Bryn Lewis, our other counterpart over here.
Yes, partner in crime.
Golf clap. Yes.
How do I get the projector working here? Oh, cool, we're good?
Number 4.
Yep, done. We're sorted.
Just fill the projector up with stuff.
Okay, stuff coming.
So just quickly what happened here, the guy who was going to do a session over here unfortunately got sick, so we had to cancel that one. So this is all a little bit ad hoc. So if we drop in the occasional swear word because we're nervous and we don't know what we're doing, then please forgive us on that one. Yeah.
All right. So we're just going to ramble on about all kinds of things.
Sorry,
like
is it-
IoT, machine to machine. Have you ever heard of that term? M2M, SCADA, supervisory control and data acquisition. Kind of sounds like IoT, but maybe 20 years ago. Yeah, a bunch of us have been doing this kind of stuff for a long time. And, you know, while Bryn's getting set, golly, look at all that. This is great. This is great. There's no shortage of fun happening here. Everyone's going to walk away with their own device, right, Brent? Is that right?
Yeah.
Yeah? Okay.
I think the Finance Committee would
Finance Committee. Excellent.
would not approve that expenditure.
Excellent. You know what? I'll tell you where I got started in IoT, just to kind of kick off with a little storytelling, since I'm the non-official storyteller of Microsoft. I guess he was yesterday. Yeah, I don't need pictures. We get that. That's better. So, you know, long before we had, you know, a lot of people are like, why is IoT such a hyped thing right now? You know, the last couple of years, you know, it's coming together. And I think, you know, in some of our other sessions, we've talked about it. Obviously, things like this is helping it. You know, there's this like parallel thing happening, this whole maker movement. And sometimes people will confuse the two, but there's definitely some overlap. But it goes back a long time. You know, so much of what IoT is, you know, you've got this little thing, a device, a sensor, or a collection of sensors, whatever it is, and it's sending the state about itself somewhere else. And you might say, what's new about that? Because I seem to remember getting information from astronauts on the moon in 1969 using telemetry and wireless and stuff like that. So it's not like we just invented this last week. Because when I talk to different audiences, some people either think IoT started 6 months ago, or they've been in the business, like especially discrete manufacturing, industrial world, where they've been doing machine to machine for decades, and they'll like roll their eyes at you and go, yeah, whatever, this is not new. But what's new is what makes it disruptive is the economics of things. The size of the compute has gotten so small, it's gotten inexpensive, it can run a little batch for a long time. Wireless has become more pervasive, which helps. A lot of facilitators, kind of that perfect storm comes together to make something that maybe before, you know, wasn't accessible to everybody. And so now we all get to play.
Yeah, if we could summarize that, basically there's been 2 movements that has brought this change about. One is the democratization of the actual devices. They're cheap, they're easy to come by, you don't have to order them in units of 1,000. So yeah, it's really easy to get things like little pies. The other one is the infrastructure necessary to make sense of the data that is coming from these devices. Today you can get these units with very small, very cheap data modules on them, GSM data modules that'll send things through a cellular network up to the cloud for you, right? You don't have to invest in millions of dollars worth of communications equipment to make this happen. You don't have to buy your own server racks to process this data. You just put your credit card in and you're done. Right?
Can't they just do this with a web server and a database?
You can.
Access database?
You can.
IIS,
You
maybe?
can.
I bet you it'll work for a few hundred.
Yeah. So how are we doing over there, Bryn?
Pretty good.
Are you going to show us some of these?
Yep. Figured I'd start with the smallest
Democratizing?
one. This is a DevDuino.
And this is kind of like a Reddit Ask Me Anything, so we're not just saying it when we say we want it to be interactive. Please just bombard us with questions, and we will absolutely try to answer anything we can.
One of the things that interests me is the competition's changing. Who would have thought that Honeywell, a company founded in 1906, is now competing with Google in the household thermometer market? Yeah, 2010, Nest
Right.
launched itself.
Isn't that wild?
A couple of years later, and now Honeywell and Google are going head to head.
And Nest was designed by the guy who designed the iPod.
Yeah.
Who knew?
So,
Strange bedfellows.
Who's
All
ever
of-
seen a Nest? No? So a Nest is this round little thing that you basically paste to your wall, and you hook it up to your central heating. This is a big machine that uses gas or something like that to heat the air and pump it through your house. We don't have heat pump. Well, we don't have central heating in New Zealand.
Okay.
Yeah, we use like radiator heaters.
Oh, because you got a lot of goodness
Well-
underneath, because this whole place is
Yeah.
about to explode.
Exactly. We try not to warm the place up too
Kinda
much.
like Iceland?
Yeah.
Okay,
yeah.
all right.
We minimize our global warming by using smaller heaters.
I really appreciate that.
I thought we just wore more jerseys. There's no such thing as being cold, it's just being inappropriately dressed.
Yeah, exactly. So the Nest thermometer is this round little thing that you base, you hook it up, and it sends its data out to the cloud, and there's a web portal that you can use to see what's happening with your house, with your temperature. There's also an app that'll communicate directly with this thermometer thing, and then you can use that to intelligently adjust the amount of power that goes to your heating device. You can see really cool graphs and things like that comes in to show the temperature of your house and how it fluctuates, and do other clever things.
Kind of learns too.
Yeah, it's intelligent.
Yeah,
There's like machine learning involved.
yeah. It's kind of like the beginning of Skynet. That's how they wanted to get is have these Nest thermometers in everyone's house. That's, it's really subversive.
Yeah,
Yeah.
yeah. Really, one day they're all just going to switch off, and half the population is going to freeze to death overnight,
There you go.
just like
That's how
that.
the machines are going to win.
Of the Nest thermometers, none.
Okay.
Oh, of these devices,
Maybe one.
let's ask Bryn.
There are a couple of RPIs which are running 10 in the selection of devices. So we've got the smallest one, which is a DevDuino, which is a Arduino clone. You can see from the size of my hand, they're pretty tiny. They're powered by a little watch battery. They'll run for 6 months on that. That sensor hanging off the side is a temperature and humidity sensor. You can do a solar-powered version with a supercap. These little wireless modules here have got a range of sort of 20 to 30 metres inside your house, or you can go for the Tim the Toolman Taylor more power option and get one of these, which will do about 1 kilometre. So you combine that with one of the shields, which it bolts onto, or for example...
By the way, what is a shield?
Okay.
For our audience members who may not know.
A shield is a way of adding additional functionality to your Arduino, your Starduino device. So this, for example, is a wireless shield. These come out of Oz. And you grab your device and just clip it on top, and then plug the wireless antenna in there. And you've got a field gateway which can upload data to Azure. This device has got a Ethernet jack on it. Or you could equally well do it with this one, which has got a Wi-Fi capability and a SD card. So you store your configuration on the SD card. You can edit it with like Notepad, Visual Notepad.
So would you just characterize like shields as basically an easier way to extend your Arduino rather than always having a breadboard and doing
Yeah.
pins and all that?
Reduces the chances of letting the smoke out of your electronics.
Excellent. Less smoke. Good.
Less smoke.
Yeah.
And
Yeah.
then,
Want the smoke to come out, it serves a cooling purpose inside the chip.
Yeah.
so you can do things with the shields and make them even more.
Can you
plug and
raise the
play.
shields?
Yes,
Okay.
in phases to stun. So, if you want to build something which acquires data and, say, uploads it to a cloud-based service, say an IoT hub, you can
I don't think we've disclosed that yet, have we? Oh, sorry. You're fired.
chuck a shield on top, and this is one from a crowd out of China which lets you then plug more devices into it. So this is a particulates detector, PM2.5, PM10 pollution. Uses a beam of infrared light across the slot and a resistor to generate some heat to draw. So you plug that in there and write some code to read it, and then chuck on a temperature sensor. Some of these need to be unclipped quite keenly. So
It's reading particulates, is that what you said?
Yeah,
Okay.
PM2.5 and PM10.
Okay.
So that's your new pollution monitor prototype with temperature and humidity and PM10.
It hits home when we talk to when you think about IoT in the past and where it is today. So a long, long time ago, I used to drive submarines, and I absolutely remember, I was on a Trident submarine with nuclear missiles and stuff, but nuclear, I'm W.
And
Nuclear. Yeah, Yes. Remember, did you learn about fission in school and all that kind of stuff? And the nuclear genie? Anyway, I remember watching some film. So, but we absolutely, the same kinds of things. I remember on the submarine, you'd have these sensors everywhere detecting different types of gas, like a zillion types of gas and particulates, radiation, all kinds of things. And it kind of goes back to this Groundhog Day story of what's old is new again. These things were around 20, 30, 40, whatever years ago, but they were just horribly expensive and they were only used in industrial settings where you had a lot of money to do it. And now he's wiring it together right there under the Elmo, and it's brilliant.
So if you're interested in mobility, this device here is a gyro compass. Gives you rotation, X, Y, and Z, a accelerometer, and then a compass. So the
compass is useful also in a plane or a sub.
Yep. And then if you want to know where your device is, it's going to be a nightmare packing this back up again. Serious nightmare. You can combine that with a wireless box. Wireless. A GPS receiver. So this kit here is a GPS receiver. That's the board that clips on top, and then that's a mag mount base. You've got an SD card for recording telemetry. You grab a device, you chuck it on top, and actually you grab that and that. Some of the kids I work with at Code Club use this gear. So if you pop that on there like that, and this was one of my students built this particular setup. This is now a downhill mountain biking black box. So we've got a GPS, so you know where you are, an accelerometer, so we can see what you're doing, and there's an SD card on the very bottom device here, mini micro SD, to record your travels down the Port Hills in Christchurch. So you can sort of clip stuff together and prototype your idea without having to invest a lot of money. There are some pretty wild sensors, like water flow sensors. So some kids are doing a project measuring water flow. If you get really serious, we've got EMG sensors, stickers which go on your arm to measure muscle activity. Last year, I did a preso here at TechEd. In the middle of the preso, I thought, geez, my arm's a bit itchy. And I had these sticker patches, here they are. These self-adhesive patches which go on your arm and the electrodes clip onto them. And I was controlling a lead bar with muscle contractions. Turns out I'm allergic to the glue. I'm standing about halfway through the press, I thought, geez, my arm's itchy. Keep on going, get to the end, and I've got these great big wheels on my arm. So you learn a bit. The kids were looking at these, they were keen. They got the muscle activity one, and I've got galvanic skin response, which is sweat, and we've got pulse rate.
Can you use that to build a truth detector?
That's what the kids wanted to build. They had the pulse rate monitor, sweat, and so forth sorted. My demo was going to be a toaster.
Of course it was.
For the
internet toaster.
Yeah.
Yeah.
It's like the hello world of IoT, right?
Yeah. It's like nirvana. And I even went to the extent that the finance committee approved the purchase of some thermocouples. So I was going to measure the temperature up the element so that you could say the bottom of the element is at X degrees, middle and top, and then use a resistive loop to burn the toast a wee bit and use some image analysis and machine learning. But it sort of got out of hand, so I figured something simpler. So this is a thermocouple, which is designed for measuring high temperatures. There's a sensor on the end, and you just wire it up, and that'll do, I think, like up to 300 degrees, whereas a sensor like this, which is waterproof, will do up to 125. And basically you grab that, plug it into the top of the shield, start writing some code, and it just works. Well, it works the second time after you read the instructions.
So is anybody here an electrical engineer? Either am I. And I can still do this stuff, so we're all good. Does anybody here write code? Yeah, of course you are. We're all developers. We're at a Microsoft conference, right? Isn't this a developer conference?
So there was a question about Windows 10, right? Which of these devices run Windows 10? Well, let's start by clarifying what is Windows 10 for IoT. Okay? Windows 10 IoT Core is a special version of Windows 10 that is headless. Okay, so it doesn't power a screen, it doesn't have UI and such. I lie, it's got one screen that says I'm on, and you can connect to Wi-Fi. But basically, you write a UWP app, you deploy it to your Windows 10 IoT Core device, and that is the entire shell of your device. Boots up into your app. If the app crashes, the device reboots. Okay. Now, there's two devices out there at the moment that runs that. One is the Raspberry Pi 2 B class, and the other one is a Miniboard Max. We've got a Raspberry Pi downstairs in the hub with all the Microsoft devices and stuff there. There's one there running a little browser app that is pointed to the Ignite website. So
That's cool.
yeah. So if you want to have a look at what those Raspberry Pis look like, go have a look down there. It's in a little case, and also pretty cool stuff. There's other devices coming along.
There's something. Qualcomm has a device coming out. You know how they make the Snapdragon processors for most of the phones that you carry. So they've got based on their technology, they've got something called the Dragon Board coming out. In fact, it's ready. In fact, I've already ordered it. It hasn't arrived yet. I got an email saying, well, we're still getting through the FCC or something like that, but you'll have it by the end of September. But it's, I think we're going to see an explosion of what we call single board computers, where it's all stacked on there. So, the Raspberry Pi 2, obviously the reason Windows 10's running on it is it's got quad-core, 900 megahertz, it's Broadcom processor, Giga RAM. You boot the whole OS off your SD card, and the storage is all on there too. Then you got a bunch of USB. You can plug in dongles for Bluetooth and stuff like that. The Dragon Board is going to come with even faster quad-core CPU, or maybe it's dual-core, Giga RAM. It's going to have storage on board in addition to using an SD card. It'll have Bluetooth for LE, so you can do some of that cool low-energy Bluetooth stuff, and maybe even beacons with it. It'll have Wi-Fi built into it. It has other things. Yes, sir? You know what? I think it'll be both. That's a really good point, because when do you cross the line from maker hardware to commercial hardware? Because yes, we'll get sand kicked in our face from all the people who are using Siemens PLCs and stuff in the industrial world, and they go, "Ha ha! Look at you with your little toys. We would never put that in production." I think the Qualcomm is going to be the differentiator. I think Qualcomm is going to find its way, but the cool thing is, it's not like it's some giant leap for you or some alien machine that you don't know how to figure out. If you can do the Pi with Windows 10, you'll be able to do the Qualcomm. It just has more capability, and it probably has the name Qualcomm behind it that people trust. And so I think it's a great way. I don't know if anybody went, not the last session, but the session before in the theater. Emma did a session just on career stuff, but she said something really funny to me in the session. She mentioned someone gave her career advice, and one of the things was, well, whatever you do, maybe it should be something that would be notable to be on the 6 o'clock news. In case you haven't gotten the memo yet, IoT is like the #1 cool thing on the 6 o'clock news right now. And so the skills that you will build doing things with Arduino or on Windows IoT Core on the Pi will translate and probably get to big paying, awesome jobs and things like that on Qualcomm and things to come. Because I think it's a gold rush right now. People are just swooping in.
I think the important conversation there is what is the migration from being a maker, playing with a $35 Raspberry Pi, to shipping 1 million units a month, which costs you 35 cents each to make, right? I'm not very clear about how you go about that, but I'd say this is what gets you the investment to go figure it out for yourself, right? You're going to build your prototypes with something like a Raspberry Pi. You're going to get an investor. You're going to start setting up manufacturing relationships, probably with someone in the East. Although there are, a while ago at an IoT panel, funnily enough, I met a guy who has a company down in Christchurch, and they make these small egg-shaped detectors, sensors, that uses Bluetooth to send back information about the viscosity of the fluid that they're in. And so what you do with these sensors is you drop them inside your wine vat. Drop a few of them in there, and you get temperature readings and viscosity readings and all kinds of things from various parts or points in the wine vat as they swirl around. And it's giving them a lot of interesting analysis about what's actually happening in there. they are manufacturing those things here in New Zealand. So it's not necessarily a case that you have to go to the east. They can do it cost effectively over here because the margin on those is such that the cost is being eaten up by services and sales and things like that. So paying 5 cents extra on manufacturing just doesn't move the bar all that much. So yeah, you're probably not going to go to 1,000 units on Raspberry Pi and Windows 10 IoT Core. You'll probably miniaturize and scale down and find a 100-fold efficiency in cost. But this is what gets you started. This is what gets you the investment to pay for that, because that's expensive. It took them years to build that sensor.
How do you get it out of the wine vat?
Sorry?
How do you get it out of the wine vat?
You dive in,
Yeah,
right?
you drink all the wine. And,
They call me,
yeah.
and I just drink it till it's gone.
If you're looking at commercializing a product, there are actually .NET micro framework boards designed for that.
Yeah.
That's what they call a 40-pin DIP format. You put headers in it, which look like the headers on the side of the shields, and then you can mount that as a daughter board on your product. And those are used inside phones, top-end desktop phones, I think, and some other applications. And you program that with Visual Studio, and it's got serial input, analog input, and a whole bunch of I/O. If you're doing it with a Pi, that's a Grove Pi. Takes the same plug-in sensors as all of the other boards I've got, so you can just chuck that in there, and then put that on the top of your Pi. And now you're measuring acceleration with the device. There's also a version which lets you connect up the Gadgeteer sensors as well.
Okay.
Got one of those.
Brent, where's a good place for these folks to order all these extra shields? Is there places you like to use or online that you like to buy from?
The RF shields come out of Australia from a company called Embedded Coolness.
Okay.
And the guy there is really good. He's an Arduino man, but he tolerates me as a .NET guy buying gear from him.
Yeah, it's really big of him.
And then these come from Dexter Industries. These sensors come from Seed Studio in China.
Okay, I bought some stuff from those guys.
These little boards here.
Is that with 2, 3 E's in it? Seed?
Yes.
Yeah.
Yeah, triple E.
Yeah.
These come from Electro. And then I've got some coming out of the States. These are from GHI Electronics, who were one of the early crowds on the...
Yes, the guy from GHI just sent me some hats.
Yeah.
Maybe we could describe what a hat is.
Yeah.
You know what a shield is with Arduino, but Pi didn't have the same cool extensible ecosystem that Arduino has. And so their idea to do that is something called a hat, which is an acronym. It's not actually a very good one, but it's kind of like hardware on top. But it's and so this stuff you've got, the GHI, is representative of a hat you can kind of snap on top of your Pi to quickly and easily get a bunch of other sensors, or to make the Pi even more extensible than it was before. And I see some platforms will kind of take you from a Pi ecosystem and then make it Arduino enabled, where you can start plugging in Arduino things just by lining up the pins and stuff like that. So it's like Legos. Did everybody play with Legos? Good. That's the best way to start. If you have kids, get them to play with Legos. Yes.
Is there a, say, hub for devices, somewhere where you can go to get download plans and see what other people are doing?
Absolutely.
Yes.
Yeah, they're all over the place. Gosh, wow, there is, and you're right. You probably want me to give you the list now. Yeah, absolutely. What's really cool is when let's say you decide you want to explore Arduino, and Arduino has its own little IDE. I don't know if you went to Brent's session earlier. Anyway, it has an IDE. It's like written in Java, and you can run it, and it uses C, and it's really simple. But the cool thing is on the menu, it comes with a zillion examples built into the IDE that you can load up and try. So you don't even know what you're doing, but you can load these up, see the code, just hit run, it'll push it out to your Arduino. You know how all these boards work? It's just when it powers on, it just launches the one app, and that's all that happens. And when you turn the power off, that's how you shut it down. And so that's how I learned when I bought my first Arduino Uno R3 or whatever. I just started clicking on everything like an idiot, which is perfect for me. And then when you can get extension things. When you buy some extra shields from some of these other vendors, a lot of times they'll have a download site, maybe a zip file or whatever. You expand and you put it in this directory, and then ta-da! Magically inside your Arduino IDE, you'll see all the other examples. Because like, oh, well, how do I do HTTP? I don't know how to send data to something, and sure enough, it'll pop up.
I found the Pi Hat.
The URL. It's like, isn't it Windows for Devices or something like that? Windows for
Windows for Devices. They've got a whole bunch of recipes and getting started tutorials and stuff on there for using Windows 10 IoT Core with Raspberry Pis, which is a free download. It won't cost you anything to do anything. The only cost
Is that free like beer?
It is free like beer.
Sweet. Excellent. Even better. Yeah.
So you just buy the device and you get all this other stuff free, and then from there you just kind of follow your nodes. And there's lots of forums where people talk about this stuff. There's some forums on the Windows for Devices page as well.
So a lot of people raise their hands when I said if you're a developer. A lot of how many .NET developers do we have? A whole bunch. So you know what I hear all the time from people? They'll say, well, back when I was in university and I learned C, but I haven't done it in forever. How many people learned C in university? Or, okay, how many people are still doing C today? See, it drops off like a rock. Here is some advice from Uncle Rob to you today. You may want to think about going back and learning C again or brushing up on your skills. Because while IoT Core, you're going to get to use .NET and all that stuff, but as you explore this world and you want to get broader and, because especially we talk about commercialization, when you get to really tiny devices, it's not going to be a Pi, and it's probably going to be something you're going to need to write C code. And there's an obvious reason for it. You need it to be small, and it needs to be as fast as possible. Just kind of common sense stuff around things, because the stuff you're going to ship in high quantities is not going to be a Pi.
There's a lot of stuff being done around Node on these kind of devices as well. Well, what happens when you're running Node on an Arduino is that there's a Node runtime written in C, and your code is running inside that runtime. When you start minimizing, you have to think about things like battery life, right? That now suddenly you're trying to power this thing off of a little watch battery instead of plugging it into the wall. You don't really want to run a whole Node runtime off of your battery if you don't have to. So at that point, that's when you drop back down to the C, and just you want to look at things like that. Yeah.
You also end up having to learn a bit of basic electronics. So this is a joystick module with a RF module. This RF module has a range of 1 kilometre, and it sends 32-byte packets. The 32-byte packets can go at up to 2 megabit, and you just need the shield to fit it, and then you can put it on this joystick shield. This joystick shield was originally created by the Arduino community, and it works really well, except it needs a custom Brin modification to make it work. You'll see the jumper wire there.
Is that trademarked?
Yeah.
Custom Brin modification?
It's in the Arduino world, you tend to poll a lot, so you go, are we there yet? Are we there yet? Are we there yet? Are we there yet?
So like kids in the backseat of the car on a trip. Are we
Yeah.
there yet? Yeah.
My son's like that. If you've driven south out of Christchurch, I've got friends who live in Wanaka, Trevor, and we're going to Wanaka, and by Ashburton, Reese is going, are we there yet? And it makes for a long and painful trip, whereas my daughter, she says, wake me when we arrive. And that's pretty much the Netduino model. This hooks up an interrupt line off the chip, and the RF chip says, I've sent what you gave me, or I've just received something, or something's gone badly wrong. Please come and check and see. So great thing about that is you can reduce your power consumption by hibernating the device. You can then, say, combine, if you're wanting to power a device, you can use a shield like this, and this shield sits on the top of a Netduino or an Arduino, just whatever one came to hand first, and it's got all of the electronics to drive this. So you can prototype a solar and battery powered app. So this is a solar panel. These are sort of $5 or $6, and you plug that in there. And we're now charging a battery, so if we grab a battery out of the box, here we go. So now we've got a solar powered telemetry system. How's that? Yep, we can see the battery. I'll clear some of this other junk out of the way.
Very sustainable.
And then,
I
say
feel like
for
I'm at
example,
university right now. The professor is right here. This is great.
and if you wanted to give it a cellular connection, this is a 2.5G cellular module, which has the bonus of you can offload your HTTP work to it. And then you chuck a sensor board on top of it, like that. So this is your prototype telemetry system. Chuck that on top. And then, say, for example, you wanted to measure, where is it? These sensors are range around about the $9 each. Say, for example, you wanted to remotely telemeter the moisture of a paddock. For your proof of concept, you can just grab that, which is a moisture probe, plug that into the analog input, like that.
Would moisture farmers on Tatooine use something like that?
And then you're away. Or if you were wanting to monitor stock water, you could plug this into a digital input. So now we have a system which is uploading via a GPRS link, the water being applied or fed into the stock trough, and the moisture of the soil next to it.
Wow.
And that's $9, $40, and $15. And then better turn it off before I unplug it so I don't let the smoke out. The device on the bottom is the most expensive. So that device is $69. That one's got Wi-Fi, and it's the latest and greatest thing. But if
there's some pretty cheap Wi-Fi modules I've seen.
Yep.
That you can connect, just wire up.
If
They're
you
like $5 or something.
The Fez Spider device, which I had sitting here just before. Oh, Fez. So this is a .NET board. It runs the .NET micro framework. They're $25 US, and it's got an SD card on it.
Do you think you could pause there and just kind of explain to everybody what the difference between the .NET micro framework is on a certain device versus maybe the universal apps that we're doing on Windows 10 IoT Core?
So at the two extremes, he says lifting some more gear off to make some space. This is going to be a mare to pack up. So on the Pi, you're running Windows 10 IoT Core. I can download apps written with Visual Studio 2015. Then these are the sort of the major platforms you'll encounter. There's Arduino, C, C++ with a wrapper around command line compilers with a Java IDE where you debug it via serial printfs.
Excellent. And that's how we started doing programming a million years
80s.
ago. And web development.
And
print. Yeah.
There's a plugin for Visual Studio 2013 and soon to be 2015, which gives you Visual Studio support. So you can actually put breakpoints in, but you have to re-download the code because the Arduino runtime won't let you modify the binaries because it makes it more robust. This is an entry-level .NET micro framework. So that's an entry-level one, and this is the Wi-Fi one is a full noise one, or an Ethernet one like that. These run on an ARM processor. They don't require a memory management unit. And the .NET micro framework is like the full framework, except a lot of the overloads are missing. So for string manipulation, you go string dot, and there's a big list of things. You can uppercase it, lowercase it, split it. On the .NET micro framework, most of them are missing. But you get used to it. It means you have to use the limited palette that you've got better.
Yes. You know, some trivia around the .NET micro framework. Does anyone remember when Microsoft really did launch the first smartwatch way before all these other people did? It was called the Spot Watch. And anyway, it was a watch. I think we came out with it in, 2005, 2004, I don't know, somewhere back then. And it was powered by the .NET micro framework. And the .NET micro, it didn't need another OS. It was just like you could put it right on the metal. And one clever thing about the watch was it used unlicensed FM radio frequencies to send telemetry data down to your watch to give you like sports scores and the weather and things like that. And so in whatever city you were in, there would be a designated FM station, whatever, that would send it. And that was the genesis of the .NET micro framework way back when from the embedded team.
2009, they open sourced it.
Yeah.
So you can, if you're very brave, you can download the source code for the .NET micro framework, the designs for the board, and build your own boards based on these boards. The Netduino guys are pretty good. Chris Walker, he's published everything. So say, for example, you wanted to do one of these, but you wanted more sockets or less sockets or in a different form factor to fit inside your enclosure, you can download it and modify to your heart's content.
So when the folks in the audience hear NetDuino, that means that it'll run with .NET Micro Framework?
Yep.
Gotcha. Versus Arduino, where you'll use C.
Yeah. So you can also use VB.NET.
Excellent.
Okay, I haven't got any of those here. They're at home. But .NET Gadgeteer came out of Microsoft Research in Cambridge, and they wanted to explore IoT stuff, so they got a bunch of sensors and devised a standard, which looks like. Oh, I can't see it. They've got their own standard for plugs and sockets, and it was largely developed in cooperation with GHI Electronics, the crowd who make the Fez device there. Oh, here we go. Here it is. So they use these sockets here, and this goes on top of a Raspberry Pi or on top of one of their boards, like they've got. They're all dinosaur names, like Raptor and things like that. And they actually do these little modules as well, and they sell them for cars and systems in cars. So the .NET Micro Framework,
like that IoT Jeep that we drive off the road?
Yeah. It's one of those unexpected things. They use the infotainment system and then jump from the infotainment system across CAN bus and then broadcast packets on the CAN bus to take out the other devices on the CAN bus. It was a CAN denial of service.
They just hadn't fully beta tested all that with real people and crazy people.
But the scary thing was they posted our update memory sticks.
Yes.
To some of the customers. So if I was a bad person, I might be quicker than Chrysler posting out updates.
Absolutely. Yeah. Isn't that weird? Right then, a new age. You didn't just see the hack of a car remotely, but then you saw an auto manufacturer respond by saying initially, hey, we're going to give you this thing so you can flash your car, the firmware in your car. What kind of world are we living in where people are going to flash update their car's firmware? And then they realized, well, that's crazy talk, and now they did a giant recall.
Because you imagine Jeep.dll is missing abort, retry, ignore.
Absolutely.
So my boss has got one.
Oh, great.
It could prove a career-limiting move if I pointed that to him. You mentioned RF modules. That's a Wi-Fi module. That gives you...
I think I bought that one.
Yeah, it comes out of China.
Yeah.
The company built it and the manuals were in Chinese, but now they've been translated, which is a bonus. So with the .NET Micro Framework, it was open sourced in 2009, which is pretty impressive. You can actually do this all open source if you're that way inclined.
Does everyone also know that this hardware is open source too? People always think about open source and software. That's the differentiator here. These Arduino, it's all, you can make you don't have to buy an Arduino Uno from the guys in Italy. It's like, no, here's the schematics, here's everything, build your own,
And the schematics are useful because this is another custom Brin modification. You'll see there's a pin missing in there.
You must be a millionaire. Wow, you got all this
a glob of solder there.
Brin.
Yes, Brin TM, or modified by Brin.
Yeah.
This is a device for measuring power consumption. So you pop that on top of your NetDuino or Arduino and combine it with, have I got one here? There's too many.
I think he could have a TV show in the morning, Saturday morning. Yeah, kids would watch it.
Yeah.
I think it'd be brilliant.
My own kids would watch it. I don't know how much appeal it'd have beyond that.
This could be the biggest thing since Mr. Rogers.
Because that board is a current sensor. You combine it with a current clamp and you put it around the phase wire of your house, and you can work out how much power your house is using. We were looking at doing a project with some kids who are at a rural school, and they wanted to monitor how much electricity it was taking to pump the water to keep the cattle fed and watered. So I can't find a damn sensor. Now, this is a good one. They also do a line in gas sensors. This is a little gas sensor. And they get optimized for different sorts of gases like LPG, town gas. There's the current clamp. So this board, plus one of these, you just plug that in there, and that goes around the phase wire in your power box.
I built a prototype of this. And down the road from where I work, there's an electrical company who do household wiring. And I walked down with an extension lead where I'd carefully slit the insulation open and pulled the phase wire out. Went inside and said, "Hi guys," and they looked at me and I said, "I was wondering if you could help me. I teach kids how to program and I'd like to be able to do this." And they looked at my length of wire and said, "Mate, that's not going to end well." And built me a series of boxes about the size of a block of butter with a power lead on one side and a power socket on the other, with a screwed down lid and no holes big enough that little people could get their fingers in. So this clip's on the top of there, and Holly, who's my star student, we run some girls only code clubs. She built some code which runs on a Arduino, which reads data from the current clamp and calculates power consumption in kilowatt hours and cents per hour.
Wow.
So we ran it at a school and she disappeared, and then she came back with all of the kitchen implements from the teacher's cafeteria, like the sandwich press and the jug, and they had some other kitchen implements, and she was working out how much power it consumed. Now, back to the gas sensor. So
Yes.
a while back, someone built a project where they mounted this on one of their co-workers' seats.
I knew this was coming. I really did.
Their co-worker's seat had a Twitter feed,
Oh, God.
which at its peak had 1,500 followers. I was thinking, some people have way too much time on their hands.
There's a lot of people like that.
I think there's one, yeah.
Yeah.
So,
Wow.
how many of you use Jenkins or something like that? So, if you're using Jenkins, you can use the smaller version of this. So your Jenkins has got an HTTP interface. So rather than using the flat screen TV, which can be hacked because it's got 2,000 plus vulnerabilities,
Absolutely.
you can use...
Did you say a new one every day?
Oh, imagine the appliance guy arrives at your house to fix your dishwasher and goes, they always do the big suck before the bill's going to be large. So
Right.
mate, we're going to have to chuck this out because I can't patch it.
Yeah, right. I
You-
can't patch your smart TV.
Your 5-year-old smart TV is now a security risk, so you're going to have to bin it. So
I'm never buying a new car again. Everything's going to be from the 20th century from now on.
you can fix it with a shifting spanner.
Okay. And
So-
typewriters, too.
So say, for example, you had a build box and you wanted to do a project and you wanted to get your boss to pay for this kit rather than having to talk to your family about doing it. You could get a Netduino like this, or an Arduino, doesn't really matter. So, sits on your network, it's got a LAN socket, 10100. It'll do an HTTP request with HTTP web request. It's really comfortable, easy to do. Chuck the shield on top, plug the relay in. You'd put this inside a finger-proof box because you don't want your co-workers doing the 50 hertz dance. But that, plus a LAN cable, equals the lava lamp for your build box.
Ooh.
So you could get the Austin Powers lava lamp, which when your build fails...
Yeah, baby, yeah.
Yeah.
All right. Excellent.
Now that could rapidly go very, very wrong.
So over at TradeMe, they've got a chicken thing that makes this chicken noise whenever the bolt passes. It freaked me out the first time I was there. It's like, what the hell is this chicken noise? Yeah.
So you mentioned earlier something, depending on the board and how much power it has, CPU cycles you can get through it in the RAM, you may or may not be able to meet the security requirements for some, like Event Hub or something else like that. Your ability to create an SSL tunnel
Yeah.
might be limited.
You may encounter some challenges.
Yes, and this is important for folks to know, because while you can do lots of great things on lots of devices, some will be precluded. So there's a lot of people who will think about all these sensors and devices out there, and they think they're all going to talk to the cloud. They're all going to, at least if you're playing in Microsoft LAN, you'll go to Event Hub and send that telemetry in. But our big worry is, we don't want to create the, biggest security attack surface in the, history of computing, which IoT could be if we don't do it right. And when you figure that most of those low-end sensors, or devices are wholly incapable of creating cryptographic anything, or SSL tunnel, then you probably won't have those. In fact, the way we're doing it at Microsoft is you just don't even get to play. if you can't meet the certain requirements for data ingestion into our pipeline for Azure IoT, you just can't do it. And so you will have to look at other things. You mentioned the term field gateway earlier. Let me describe what that is kind of like, even though some people have different terms for it. Imagine I'm in a factory building cars or whatever, and I have sensors on my assembly line and all over the place. They're giving me all this great information to run my business better, and there might be thousands of them. And one school of thought is, I'm just going to have all those sensors send all that stuff to the cloud. But the reality is you won't go, well, yeah, we got IPv6, we're just going to do it. The reality is and the way it's not being done today also, because again, a lot of these places have already been doing this machine-to-machine stuff for a while anyway. So the reality is we all know what a router is. It's at your home or whatever, or it's in a business, it's at the edge, it's in your network, and it's kind of the gateway to going out to the internet or to wherever. And so the reality when you see these big scenarios is you'll have all these sensors, and they'll all be talking to something that's called a field gateway. And think of a field gateway as a router. So, and especially, and they'll do lots of different things. For instance, there's so many different wireless protocols in use that many of you have never heard of, like Zigbee or Z-Wave, or 6LoWPAN, Thread, all these things, Sigfox. So there's all these internal ways to talk. And so you might have this field gateway, imagine a hardware appliance. It is capable of communicating via any of these wireless protocols, as well as Ethernet and maybe even RS-232. So it's got to be able to do all of that. And then it also may have to do what we call protocol translation. So your cloud, where you're going to send stuff to, sort of in our case, Event Hub, it wants you to send things via this advanced message queuing protocol, AMQP, that was created on Wall Street. It's really good, efficient protocol. If it's good enough for all those high-frequency traders, it's going to be good enough for your IoT devices. But you can also do HTTP, REST, JSON as well. So we all have different wire protocols. All these different sensors may be sending things, talking different ways. They may not all be talking REST JSON. They may not all be talking AMQP. They might be talking MQTT or CoAP. Or there's myriad protocols that are in use in this world. And so it has to do protocol translation too at the edge. And so a lot of times you'll see a field gateway. That's a responsibility of the gateway as well. So imagine it's kind of like a listener. Sitting at the edge, you guys are all the sensors coming to my edge device here, and the cloud's up there. So I'm listening like a web server, and all these things are coming in, and so it's going to do all that work. The other thing it's going to do, you'll have a range of field gateways. You'll have dumb field gateways where it will just mindlessly be a router and take all that data in and send it onto the cloud, but through one stream rather than maybe 10,000 streams. Then you will also have incrementally more intelligent field gateways that'll start making maybe some basic decisions. If I have 10,000 sensors in my factory and every minute they're saying, I'm okay, I'm okay, I'm okay, I probably don't need to send all that to the cloud. And so your gateway will catch those packets and drop them. And so there might be some simple logic, maybe kind of like, you're like, if this, then that type logic, right? On all kinds of things. And so you'll see gateways do that, more and more rules-based logic on what to, because sometimes maybe can handle some issues right at the edge. I'm certainly seeing folks with gateways that do that. And then sending just the really critical or the anomalous, the really obviously anomalous packets onto the cloud for further analysis. And then I've even seen some startups that are producing field gateways that are doing full analytics right at the edge. So I think that's just another component of this whole world, especially the evolution of what is called machine-to-machine. There's all these consortiums, as you might imagine. There's one that's called the Industrial Internet, or IIoT, Industrial Internet of Things. That's kind of heavy industry that's been doing M2M and SCADA for a long time. And so there's a lot of stuff around that. I mean, this is serious stuff, and this is going to be great for all of us who are opportunistic and jumping on this wave. Like you see all these different tidal waves in your technology career, like the PC and then the internet and the web and then mobile. And now we've got IoT as the next mega trend. And so like in Germany, they call this Industry 4.0. I mean, they think this is V4 and one of the biggest parts of the Industrial Revolution ever. And so while we're talking about lots of fun stuff, and this is absolutely where you need to get started, there'll be a world of this industrial world where you'll have hardcore stuff that you'll be working with that is going to make a huge difference. And you see all these analysts talking about crazy numbers. how many trillions of dollars?
14 was the
$14 trillion industry. So grab onto that. But anyway, is your own knowledge about the IoT space and the industrial IoT space. Field gateways are a big part of that. And you can actually build a field gateway. Like, for instance, let me just conceptually walk you through. Let's say you had a Raspberry Pi with Windows 10 IoT Core. And even though it's stripped down and it doesn't have all the other stuff that big Windows has or Windows Server has, and you can just write one headless program, or you can write a GUI, a universal app if you want. But let's say you write a headless program and you just have a TCP/IP, listener, HTTP listener on there, and that listener is listening to all those devices inside the factory, and then you write code in C# for your little rules engine. And you know what? Guess what else runs on Windows 10? SQLite. Maybe I need a little intermediate database to store some stuff as I'm making decisions on things. And so I'm catching, almost like you're building your REST services, I'm catching packets coming from all my internal sensors, making decisions. And then I'm going to just use my libraries for AMQP to send the good stuff up there. You could absolutely get in the field gateway business, by midnight tonight if you wanted to, and get some code cracking. But what do you think, Bren?
I've got a field gateway here. This is based on an Arduino. This is a TI wireless chip, and because the ARM chip here would be a little bit busy doing all the necessary crypto, the TI Wi-Fi chip and its antenna here takes care of all the crypto for you. So this box, this board plus this, equals a field gateway for all of these devices.
Right.
And that's basically 80 bucks worth of parts, retail.
That's great.
So
you
you
can turn
can-
around and sell it for $5,000 and tell people there's just magic inside there.
Underwriters Labs, big tick.
There you go.
So basically, that would connect all of these devices up to 255 of these other devices up to the Wild Wild Web. People talk about IPv6 as the ultimate solution, but I'm not so certain. It gives you an incredible pool of addresses, but realistically, you don't want these little devices exposed on the internet, and most of them can't do IPv6. IPv6 packets are giant. They're like 1,500 bytes, be a minimum.
That's giant.
And they reckon that it's about $50 to the cost of a device to give it IPv6.
Yeah, that's
With the
crazy.
necessary hardware, the necessary silicon, and the necessary software.
Right.
And if you're selling your device for $35 at Walmart,
Yeah,
there ain't going to be any profit in it.
not so much. We want profit.
Profit is king.
Except in Star Trek land where they go, oh, he was out for profit.
So how do we add profit to this? Right? We've got our $35 device and all that stuff. What makes this better than the next guy's $35 device? Right? It's not that hard to build this. So where you add the profit is taking your domain knowledge, what you know about IoT and computer programming, and applying it to an industrial or vertical, what we refer to. So how do you bring this stuff to retail? How do you bring it to agriculture? That is where the money is. It's about these back-end systems that does the analysis and tell people how to do things differently from how they're doing it today. Once you can figure out how you can influence behavior using these things, then you've stumbled on a way to make money out of it. Just getting the data is not good enough. No one's going to pay you for that. Well, some may pay you for that data, but that's not the profit. That's not the value. The profit is in analyzing that data and figuring out where to go to next. How do we optimize the process further? That's where things like machine learning comes in, all that kind of stuff. So
Yeah.
that's really what you want to focus on. Okay? Figure out how you can use data to influence behavior, and then go figure out how to build a device that gives you the data.
Right, yeah. Does everybody know about machine learning? I know we've had a few sessions on it so far this week.
Yeah.
And I talked about it in my sessions. We're just trying to make something really hard, R programming, data scientist stuff, easy. Make it drag and drop workflow, put in a bunch of so-called experiments. They're little algorithms that are pre-baked. You can actually create your own as well. Actually, if you know how to program in R or even Python, which is a lot easier, and you've got some great IP domain experience, you can actually, we have a marketplace on Azure, and you can actually sell those things. But yeah, absolutely, that's where the value is. And so, think of our example. We got something in the factory, the machinery, and then we built a field gateway using our Raspberry Pi and Windows IoT Core, and then we're sending it to Event Hub using AMQP or whatever, and then we go into this pipeline of analytics, and it goes to machine learning, and it keeps sending data about all this machinery, and machine learning is going to do predictive failure analysis for you. And it's going to tell you, the owner of the business or whatever, when this piece of machinery is going to fail or when a component's going to fail. And so because of that, now you're not going to have downtime, or you're not going to have customer service problems. You're not going to be losing money. That's the value. You're right. I hate to say it's not a science experiment, because it looks like we have a science experiment here, but that's fun, and that's where it all begins. But then where we turn the fun as science into dinero, it's the outcomes, the insight from the analytics.
The most fun.
And okay, yeah.
Yeah, that's just fun.
Are you gonna ride this off the ramp here?
I'll give it a go.
Also a question?
Yeah.
Yeah, just like the setup on the screen. For example, if your sensor is only send the telemetry data every day and then falling asleep in rest hours, and you actually want to do some ad hoc, maybe a person that nearby that sensor want to wake it up. What's the best way to do that?
If you have a technician come to it who needs to wake it up.
Yeah.
Quite a lot of devices use, if it's a mobile device, an accelerometer.
So these little accelerometers here, just make sure I've got one. Yeah, that's an accelerometer.
Is there anything you don't have? Oh, what they have is this. Oh, I have it right here. Yeah.
There is some stuff that I admit to having and other stuff which I have to maintain plausible deniability about because I'm not supposed to have bought it.
So this is an accelerometer. It has an I2C bus to communicate with it, which is a register-based thing. You go, give me register 1, and that'll be the high-order byte of the acceleration, and then give me register 2, which will be the low-order byte of the acceleration. But the other thing you can do with this is say, tell me when something happens. And you can then put your processor to sleep, and it's got another 2 lines on it, 2 connectors, see interrupt 1 and interrupt 2, just there. You can wire those to your microcontroller and then put your microcontroller to sleep as well. So basically everything's hibernating until the device is dropped or moved. So that's a possible way of waking it up. Or some of the kids are playing around with this. This is a RFID tag reader. And you use the RFID tags. Where are they?
You're making me feel really bad when you keep saying all the kids are playing with ... Loser up here.
So these are different form factor RFID tags. And they build a robot, and then we chuck these on the floor, and then the robot goes out and collects them by reading them with the RFID tag reader. So if you've got something where you need to know who's operating it, you can swipe an RFID tag. Or I've got some proximity things. Where are those? I've got some sensors which I've only just got, and I haven't written any code for yet, but they're actually gesture sensors. They're out of one of the video games, I think. I've got to read the instructions for them. I saw them and then they went out of stock, and then I saw them and they went out of stock, and finally I bought them. Where is it? And these have an infrared sensor on them. They're like a baby Connect.
Yeah.
And they understand gestures like rotate.
And you just hold your hand in front of them, and they're like $9 or something.
So I've certainly seen those other motion rangefinder kind of sensors.
Oh yeah, so
The kids do that with these.
The kids do that with these.
Yeah,
Yeah.
they build a backing beeper.
So yes, I've seen that. So you know what you can use that for? Remember Alien, and Sigourney Weaver, and they had the deal, and they're like, you see if the aliens are coming. That's what you use. You use that to build that thing.
my son took his Super Soaker to the beach, a brand new Super Soaker. He took it to the beach, got salt water in it, had a very traumatic learning experience for a 7-year-old. But he brought it home and he pulled it apart, and we found that the battery had broken. So he built a Super Soaker. We modified his battery-powered Super Soaker with one of these so that it shot when anything got nearby.
Oh, that's brilliant.
And he left it casually lying on the chair on the deck, and the next door neighbour's cat walked past. So the cat gets a soaking. The kids who I do the code club with, they are using these, which is a waterproof sensor, waterproof ranging sensor. So that's like a couple of meters, and it's basically the backing beeper out of your modern European or a Japanese sedan. But these are the gesture sensors. I haven't had a chance because tech ed prep, woefully underestimated every time I do it. Like 8 hours prep for every hour presentation. If you've got devices, If I charged an hourly rate for it, I would most probably be better off being a checkout operator. It took that long. So this is a gesture sensor. So that's a little chip there. It's got an infrared sensor on it. And
I think some other sensors going off.
It's that timer thing for us warbling for too long.
Oh, we're finished now.
Yeah.
Does that mean we're done?
So this is a gesture sensor. You can do that, do that, do that, do that, and it understands it. And you can then poll what's happening from your device and go, what are they doing? And it'll go, they have gestured up. So
Did that answer your question? Because you're right, you have some, because that's a big thing. We talk about like smart cities, how we're going to be embedding sensors into concrete, into buildings, and they're going to be using these ultra low power wireless technologies like, LoRaWAN and Sigfox, and they'll be running on batteries for 5 years or 10, whatever. And part of it is, like he said, they're going to be going to sleep a lot. And then they just wake up, turn on the radio when they need it, and go back to sleep. And you're right, how do you wake it back up again if you need to send a command to it? And there's lots of good examples there. Absolutely.
Cool. So we've run out of time now. I think we'll wrap that up. We'll head downstairs to the hub and go have a beer or two.
Yeah.
I want to thank Rob for jumping in and doing this panel with us. And I want to give a special applause here to Bryn, because Bryn does an amazing amount of good work with the Coding Club, with kids around New Zealand. He brings all of his little toys, and he actually teaches these kids how to code. At a very young age, he does this without payment. He does it for free. He puts an incredible amount of effort into all of this, and thanks for that, Bryn.
Thank you.
You're an inspiration.
Yeah, he is.